Thank you to Farming Smarter for the invitation to be here. This has been a very interesting project to work on. And my job today is to talk a little bit about clubroot, and then I'll pass it off to the folks that actually worked with the dogs. If I had a key message to give you about clubroot, here where we are in Lethbridge, my message to you is don't think that it can't happen here. We know that clubroot has been moving more slowly in southern Alberta than it has in the Edmonton area, but it has been moving in southern Alberta. And we shouldn't assume that it can't happen to us. And so to that end, I'm going to talk a little bit about the disease, and I'm going to go quick so that we can get to the fun stuff. This is kind of where I'm going to go today. This is an outline of what I'm going to talk about. And I'm going to start here by just giving you a little bit of a reminder of where clubroot came from. We've had clubroot in Alberta since at least the 1970s in some home gardens. There have been other major economic infestations in vegetable farms, so market gardens that grow brassica vegetables. Clubroot was first detected on canola in 2003, and our surveys have showed that there's now over 3,000 fields confirmed to have clubroot. So what is it? It's a disease that occurs on the roots of hosts, and these hosts are in the brassica family. So that includes canola. It also includes broccoli, cabbage, cauliflower, Brussels sprouts. Some people aren't sad to see Brussels sprouts die of a disease, but they're a host nonetheless. We also have kohlrabi, kale, radish, and Chinese vegetables like pak choy. And finally, we have weedy species that are naturally occurring in Alberta that are also in the brassica family, such as stinkweed, shepherd's purse, and flicksweed. There's probably 60 or 70 other brassica weeds, but they occur mostly in rangeland, not always prevalent in our cultivated agricultural soils. So these are the hosts, and so even if we're not growing cabbage or cauliflower or broccoli, even if we're not growing canola, if we have the presence of these brassica weeds in our field, we're still at risk to have clubroot become established on our farm. There are some things that help clubroot become established. Warm soil temperatures. So once we get up above 12 or 14 degrees in the soil, clubroot severity can get very high. It's also favored by acidic soils. pH is lower than 7. And this particular pathogen requires soil moisture. It takes about 6 to 8 weeks for symptoms to occur from once the pathogen infects the root. And sometimes we see symptoms above the ground, but not always. But if clubroot is present and causes a severe infection, we always see the galls on the roots, as is shown in this photograph. Now, I want to point out a couple of things. Clubroot can still occur in cold soils, like 10, 12 degrees. Clubroot can occur in soils of pH 8 or even 8.5 or close to 9. And clubroot does occur in dry years. So these things that I've mentioned here that favor clubroot, they don't exclude it. And that's the reason I'm saying we have to be on the watch and be scouting for this, because we do have some advantages in the south, but we won't be immune to clubroot. So the pathogen that causes clubroot is an interesting one, and I want to just point out a couple of things that make it unique. So probably most of you are aware that fungi can cause disease on plants, bacteria, viruses, and some of you are probably even aware that there are slime molds in the environment that decompose litter. So where does the clubroot pathogen fit? Well, it doesn't. It's not really any one of these, but it has characteristics of the fungi, the bacteria, and the slime molds. It's a protist, and some of its characteristics are the reasons why it's difficult to manage, because it's not like any of these others. And I want to point out the one that's the most important. This is a photograph taken under the microscope, and these little round spheres are clubroot resting spores. In one root that has a large gall on it, there can be up to 1 billion of these little spores just in one root. So it can produce a huge amount of inoculum, and then those spores remain dormant in the soil for 10, 15, some of those spores will remain dormant in the soil for a decade or more. So to give you an idea of the size, if we put a human hair next to that clubroot spore, that's the size of a human hair. And so they're very small, they're very durable, they survive a long time, and they just remain dormant waiting for a host to show up and then cause disease. And so here's what happens. That resting spore will germinate upon being induced to do so by certain cues, and it will swim short distances, like millimeters or maybe a centimeter or so through the soil, water films in the soil, and it will insist on the root hairs of a host, and then it will form a feeding structure and produce a secondary flush of zoospores that then produce what invades the root and causes those club-shaped galls or tumors or root swellings. And then as the plant matures and the root decomposes, those resting spores are released into the soil. This is a clubroot distribution map based on the survey work led by Dr. Steven Strelkoff at the University of Alberta. And this map shows color-coded from 0 fields, which would be in the gray, to up to 1,000 fields per county, which would be the dark red. And so you can see that we have more fields infested with clubroot in the Edmonton area and fewer fields as we move south. We generally have about 300 to 500 new fields confirmed each year. And up until recently, we've also always had a new county reporting, or 2 or 3 counties reporting for the first time. Eventually this will slow down because my prediction is that it'll eventually be pretty much everywhere that we grow canola. We're fortunate that it is moving slower in southern Alberta because it gives us time to get our management tools in order to help prevent or manage. So how do we manage? These are the pillars of management: scouting frequently, using clubroot resistant canola cultivars, no host crop for at least 2 years to help either prevent or maintain what's going on. And in some cases, if the resting spore populations in the soil are really high, like hundreds of millions to billions of spores per gram, more than 2 years would be required. And then finally, sanitization of equipment to prevent the spread of clubroot from field to field. It moves in contaminated soil on equipment for the most part. So these are the management tools. That's not what I'm here to talk about today. We also know that there's an economic cost of clubroot, and that's not what I'm here to talk about today. But if you want more information on this study that was done on potential impacts of clubroot, especially with respect to crop rotation, I'll be happy to point you in that direction. What I'm here to talk to you about today is, why are we finding 300 new fields every year? Why are there new counties every year? Why are our resistant cultivars being overcome by virulent pathotypes? Why can't we get ahead of this? At least part of this answer is because we're not detecting clubroot until we see this. We see a dead patch in the field or above ground symptoms, and we're going, what's that? Oh, I guess it's clubroot. This is a photograph that I got. I can't remember if it was Dan Orchard or Greg Sekuluk from the Canola Council gave me this picture. They found this plant. There was no above ground symptoms, just small swellings on the root. So how come we can't find this before it becomes this? So if we can detect it early, it's much, much easier to manage this disease. But once those resting spore populations get high, it almost becomes unmanageable. Well, why can't we detect it early? Because it's underground and we can't see it. And when we go to scout for it, we have to pull plants up. And if I pull 100 plants up, but I just happen to not pull the one that has the small swellings on it, I'm going to miss it. I need to be able to see under the ground. How do I do that? Well, I happened to read the same paper that Mario did about, and I'm sorry if you can't read this, the paper on the left of the screen says, Agri-Dogs, using canines for earlier detection of laurel wilt disease affecting avocado trees in South Florida. So I read this, and with avocado orchards, if the tree gets laurel wilt, the management practice is to destroy it. You just get rid of it, you rogue it out. There really isn't a lot of curative management. But lots of times, by the time you know it has laurel wilt, it's already spread to other trees that are asymptomatic. So they wanted to be able to detect laurel wilt at its earliest infection periods, and so they tried dogs to see if dogs could detect. And here's an example of one of their dogs alerting them by sitting still in front of a tree that it's detected laurel wilt. So they were successful. Their numbers were quite impressive. And not long after I read that paper, I got a phone call from Mario, who asked if I was aware of anybody doing this kind of work, and I said no. And Mario and Bill and I got this idea. We partnered with Farming Smarter, and we got some funding to investigate whether or not this was something that was a possibility. If the dogs can see underground, they can help us detect early infestations of clubroot and help us to get ahead of it rather than be behind it. So, in summary, clubroot is an important disease that causes serious economic losses, and we shouldn't underestimate it and think that it can't happen in southern Alberta. Management of clubroot is certainly possible. We have some really good tools to do that, but scouting and early detection is a very important part of this, because once those resting spore populations run away on us, there's not much that we can do. And finally, canine detection of clubroot may be a method to improve scouting and early detection. Mario and Bill and I are all gonna take questions at the end of our presentation, so I'm gonna transition now from the clubroot side to Mario for his presentation.
So I guess the question was asked, is it possible to train a dog to detect clubroot? And the answer was yes. So canola is a very big problem, obviously, in this part of the country. It's basically the world's most important crop in terms of oilseed. And basically, it's also a very profitable commodity in this area. So being able to control that disease using the method that we ended up doing is something that's new as well as very different than what was currently being done. So this was basically just to show, to give you an idea that it is a big problem, and here's basically the team that was put together to try to see if this was possible. So we had two dogs. Actually, I'll go back here. So we had two dogs that worked on this project. Josie is my dog. She's about 2.5-year-old German Shepherd. And we also had Addie, which is the golden doodle that you can see there. She was a rescue dog that was picked. And she had the right attributes in terms of drive, energy, intelligence, that we thought that she'd be a successful candidate to use for this type of project work. So Farming Smarter and the Alberta government basically asked a question, is this something that could be done? So, Bill had received the question from me and asked, is that something that a dog would be able to do? And obviously, based on his experience, the dogs have been able to be trained for multiple different substances, as you'll see later on as well. So, Bill has been working for nearly 60 years with dogs and had a lot of valuable experience and knowledge in terms of training the dog, finding different problems, troubleshooting, seeing what were the opportunities and what skill sets the dogs could do to try to help with this problem. In reality, what we're trying to do is we're tackling a problem. So clubroot is a disease, as you saw a few minutes ago, that's very, very hard to find. Right now, currently what they do is they rip out plants from the ground and inspect to see if there's a problem. The thought or the idea was, if we can train dogs to use the odor, the smell of that disease, rather than just random, you're making the ability to try to find and detect the disease exponentially better. Because you're not now going into a field and randomly looking around. You're actually going based on a scent and odor that's coming from that substance that the dog is trying to find. So it's a very, very valuable tool. So basically, as I said, I started off because I read that same article as Michael did about 2 years ago now. And I thought it was very, very interesting. I've done some scent work with my dog, and it's a hobby of mine that I've been doing for a few years, and I've always been looking at the challenge of trying to expand what I've done and try to learn new things. So when I read that article, I thought, that's really interesting. I wonder if there's anybody in Canada that's doing any of that type of work. I did some research online, and then I approached Bill, which has been working in the industry for many, many years on multiple different boards, and he's like, I've never heard of anybody doing that type of work. So we then started asking questions and contacting different people in different industries. I looked at, for example, the potato industry back home, because the potato industry is a very, very large industry back home. It's closer to our area. And I know that there's a few diseases that they've had some challenges in trying to find at the time. And I basically continued in that direction and asking different people, different provinces, and that's how I got a hold of Michael. And then he's like, well, you know what, I don't know if that's necessarily the right problem, but we do have another problem in this part of the country, and it's a problem that we're having a lot of difficulty trying to find. So that's where the thought was, to see, hey, maybe there's an opportunity to develop a valuable tool that could help the industry to tackle that problem. And the way that I see it, it's also the possibility that that tool could be done for multiple different industries and crops. It could be disease, it can be pests, it can be insects, it can be different things, but it's to find the right fit and the right opportunity and the right problem where what we are doing and what we are using the dogs for is a lot better than what is currently being done. The possibility of being able to detect a disease earlier on in the life cycle might potentially allow the ability to maybe control that disease using fungicides or insecticides or whatever other means that are necessary. But if it's done earlier on in the life cycle, you may have a lot more success to try to do that. Or maybe it's it's not just being able to detect it then. Maybe it's the fact that in order to confirm the presence of a disease may involve ground samples, testing, time. So it may not necessarily be one type of benefit, but there could potentially be multiple different type of benefits of using this tool to tackle some problems. So I'll see Bill next, and he'll be able to continue on.
Thank you, Mario. Mike, those are the two instigators of this thing. I have the fun. How many people in here have a dog? There we go. You have the fun too. Somebody told me they had a border collie. He has a nightmare fun. Okay? All right. So, canines have existed for over 800,000 years. We, or humans, have only existed for half of that. So humans didn't pick the canines. The canines picked the humans to be a source of what they wanted. Our garbage, our food, our affection, our campfires and things like that. And they knew that they could create behaviors with us if they did things for them. So dogs have always been a part of man, always been a part of man. And the education of dogs, as the education of man, has increased exponentially over that time. Okay? So, understanding the science and behavior has increased this symbiotic relationship between the dog and the man or human. We have seizure alert dogs, we have hearing ear dogs, we have allergy alerts, we have low blood sugar for diabetics, we have cardiac arrest, we have cancer detecting dogs. You can go on and on and on with what we've found out that the dogs can do for us. Never before has that happened. Years ago, all we had was seeing eye dogs. And now science and people have found out that they have so much more talents. As I said, I get the fun part. They came up with the idea. So, we are still learning the mechanics of scent and the mechanics of the dog's scenting ability. To date, the scenting capabilities of dogs for explosives or for low blood sugar or for cancer have met the equivalent of what we can do electronically. So that lets some of us in the dog world think that they can do better than what we can do electronically. We just haven't found out enough science to make our electronics better than the dog. In fact, dogs can detect a single spray of perfume in a stadium, a football stadium, or a half of a teaspoon of sugar dissolved in an Olympic-sized swimming pool. That's a fact. So their scenting capabilities, and I won't go into the physiology of the dog's nose, are so complex, and we're just starting to learn to understand them. You've heard of some of these: the police tracking dog, the search and rescue, cadaver, dead bodies, explosive detections, narcotics and drugs. Snake detection is being used by dogs in Florida to detect the not indigenous boa constrictors, to be able to find their living spaces which they're not supposed to be there. Bedbug detection, we've all heard of that one. In Atlantic Canada, we now have dogs that will detect lobster eggs on female lobsters so that the inspectors can check multitudes of crates without having to hand fish through them to find them. Gas leak detections, oil spill delineation, how far the oil has soaked into the dirt and how far it is delineated out from the spilled tanker car, etc. Cancer detection, malaria detection is being used by dogs, tuberculosis detection, diabetics, gypsy moth detection, pole rot detection. In Norway, they have dog teams by the Power Commission that go around and detect the poles that have an extensive rot in them before they can fall down and break the power lines and go without power. Hard and thumb drive detection. Dogs are being used by the FBI and by police agencies all around to find hidden thumb drives and hard drives, small miniature ones that might have pornographic children's images on them hidden in people's houses. Cortisol detection. We have dogs now that will detect that level in a person's anxiety, and they're used in courthouses now to calm down a child or a person who's had an extreme sexual experience and is nervous to give a statement. So the dogs are being used in courthouses. Mobile phone detections in penitentiaries now. All the drug dogs now are being trained to find lithium batteries for mobile phones that have been hidden and secreted into the penitentiaries. And we all know that if you don't have a battery in your mobile phone, it's useless. Ambergris detection. I've been lucky enough to train 2 dogs to detect ambergris, which is whale vomit, a sperm whale's vomit, which a chunk the size of a textbook is worth about $15,000, $25,000. So my clients walk across the beach on a Sunday afternoon and take their dog. If they happen to stumble across a chunk of ambergris, they're happy. Peanuts and allergy detection, currency detection, CD detections for false CDs, firearm detection, wildlife poop detection, accelerant detection for arson, and now clubroot detection. So the mechanics of dog training of this job: a confident, happy, eager dog is what we have for optimum for training. A dog that has not yet learned unacceptable or bad habits is obviously optimal for training. A healthy dog and structurally sound dog is another optimum need. A dog that is highly energetic is optimum, and a dog that is inquisitive and afraid is optimum. I can go into the humane societies and find a lot of optimum dogs if you're not breed specific. A lot of these dogs ended up in the Humane Society because they had too much energy, because they were just terrorizing the home, and the family just couldn't handle it, so they dumped them off someplace, and they're perfect candidates for scent detection. And a trainer must find or create this optimum subject to begin development. Now, we have a time factor training dogs. And the time factor is very fast with dogs because a dog dies of old age at about 12 years old, 10 to 12 years old. A human hasn't even reached puberty by that time and reaches old age at about 65 years old. And yet a dog's brain is approximately 80% developed at about 72 days of age. So the instincts, the confidence, the dominance are all formed by this time, and any and all additional learning is created by the experiences of training. Good or bad, it's the experiences of training. And a 2-year-old dog, adult dog, can provide 6 to 7 years of service considering health and upkeep. And a dog that's working scent can cover about 100 square feet a minute. Do the math. So the training process, when anything, any scent that we are working with or you're working with, your dog in your backyard might be an optimum dog for scenting it to find things. It may very well be. You have the clinical training and you have the practical training. And in clinical training, we have to have a target scent, and in this case, clubroot, which we received religiously from Michael's team, sent down to us in New Brunswick, where we trained 4 dogs to do the clinical work to see if they could detect clubroot. And that was the extent of our concept of our program, to see if they could indicate clubroot. So then we developed the duration the dog can work, and we developed the distance that the dog can work from the scent to the scent. After all that's said and done, after many, many hours of work, we proceeded into practical training where we introduced the dog into real life situations. And that wasn't part of the project, but we were having so much fun at it that we wanted to do it. We even introduced the dogs to wearing GPSs so they could run through the fields, find where the clubroot was, and we could look at our cell phone and see where the dog was. And we created good working habits. And the dogs were happy, happy, happy. So imprinting, conditioning, or training, they all mean the same thing. Confidence and control are objectives of any trainer, coach, or a teacher, whether you're talking about dogs, horses, or children. So you can see the pictures there. The dogs are working and having lots of fun doing it. And we build up their confidence at a young age. And this is some clinical training that you might enjoy. Now, we've taken these months of work and sped them up. So you're going to see them moving around quite fast, a lot faster than what I move around on. But this is the clinical training, preparing a dog for scent detection, and in this case, clubroot. So you can see it is very repetitive. Every day, no weekends off, morning and night, constant, constant, constant. Okay? And that is the scope that we did for the project. But as I said, we were having so much fun at it, and the dogs were enjoying it so much, we decided to challenge them further and take it out into the field, which we didn't expect to do, but we tried to do it anyway. And so another quick video of what we did to take what we did clinically and put it into practical.
So basically, as you can tell by all the videos and all the work that we've done, dogs can detect clubroot and many other potential problems that are out there. The possibility of training multiple dogs is a possibility as well. It's been done successfully in multiple different things where the dogs basically compete with each other in order to try to find what they want to find to get that reward. Existing farm dogs could probably be trained for as well as the selection and the work is done properly. But the selection of the dogs is a very, very important factor. You don't want to train a St. Bernard to try to find something in a big, large field that the dog has to work and to run a lot. So the selection of the dog is very, very important. And trainers and handlers can also be trained to do similar projects on other different crops, like I said earlier, insects, different diseases. So one dog could potentially do 3, 4, 5. There's some correctional dogs that are trained for 10, 12 various substances in a correctional facility. There's no reason why the right candidate, the right dog, cannot be trained to do multiple diseases. And the more that they can do, the more valuable that tool could potentially be. And as I said earlier, it's finding the right fit or the right problem, the right value to having a dog versus what is currently done. That's the key. So, except that, I open the floor to questions. I think that's it, eh? Oh, there.
Excellent presentation, you guys. Isn't that amazing work? We've brought the microphones out to the edge here, so they're just a little handier for people to come up and ask a question. Please avail yourselves of the microphone, or if you're close enough to me, wave and I'll bring the microphone out to you. I'm surprised, and you guys might as well just all cluster around the microphone there, and you'll be able to answer questions as they come up. I didn't hear you say that it's breed specific. I would have thought that there would be breeds that would be far better sense of smell than others, and maybe it's just country music folklore where Tennessee hound dogs are supposed to be the ones that can smell anything, but it's not necessarily breed specific then?
No, I think you're getting into racial equality here now.
Okay, yeah, sorry, me bad.
No, the physiology of a dog is the same, and some are better than the others, but it is, in average, they all have the same attributes. Now, a large dog, like Mario was saying, might tire quicker, just as a large person might tire quicker. A small dog might not have the ability to clamber over things or go through rubble if it's search and rescue, so all those things have to be considered. The scenting abilities of the dog are such that they all have the same equipment. Some that can operate it better.
How does it manifest itself if the dog detects clubroot? I couldn't tell from the videos necessarily. Does it stop and look at that spot, or does it dig in the ground, or does it bark? What signal does it give?
All of the above. In this case, the original work with narcotic detector dogs was to find it and to dig at it, but so many small narcotics were being found, and the dog had scratched up the cars and the Lamborghinis and things like that, that they adapted the dogs not to dig at it, just to sit and point to it, which environment, that's what they needed. When we started doing this with the clubroot, we thought, well, do we have to have the dogs sit and point at it, or can we have them dig it out? And we thought it better to have them dig it out. So either way can be adapted, but in this case, we did a multiple thing. We had the dogs bark when they found it. We had the dogs dig when they found it if they could, and we had the dogs sit and point at it if they couldn't do any of the other three things, or if they could do all of them.
This might be a better question for Mike, but where does it go from here? How does it get to practicality out in the field? How do you think all this great work you guys have done, how does it manifest itself in practical terms?
Yeah, that's a good question, because the purpose of our study was just to see if it was a road we could even go down, so just a proof of concept to see if the dogs could do it, and they could. So, it's really going to be, I think, up to the industry to decide whether scent detection dogs for scouting and clubroot fields are going to be something, either a service that people will pay for, or for people who are dog trainers in Alberta, whether they want to train their dogs to do this. We've definitely had a lot of people reach out to us saying they want to teach their dogs to do this, so we're seeing a bit of uptick. We think probably the next place that this needs to go is training dogs to detect the resting spores in soil that might be hung up on equipment. And so that's really how it's spreading from field to field, is on contaminated equipment. So to have dogs that could alert you not only to, this is clean, you don't need to wash it, but also if it is dirty, maybe it's just one spot and you only need to wash for 5 minutes instead of 4 hours. So, and then in addition to that, there might be other diseases that are difficult to detect, or the symptoms appear after it's time to intervene. There are some other diseases we're thinking about putting this kind of technology to work for.
What is the level of detection? Because obviously you get some soils that have a few spores, and you get some that are polluted with spores. Did you get any sense of what level of detection? Some of the information provided, the little bit of sugar in an Olympic-sized swimming pool, that's amazing. What's the level of detection for clubroot?
So we haven't done it with spores yet. All of this work was done with root galls. I'm told that the limit of detection for most odors is parts per trillion, but maybe Bill or Mario can specify for clubroot? Do you guys have an idea?
I think the only way to do it is to start with a level that's a known level and blind testing it down to the point where the dog won't find it. And then we can find that. But to date, with every other scent, nobody's ever come down to that limit. The dogs have always surpassed the electronics.
So, and this might be, again, a question for Mike, and we'll take the question from the crowd here next. Do you see it, if you had a couple of well-trained dogs, and you're doing clubroot survey, and they're taking soil samples, maybe digging up plants, do you think just from a disease survey point of view, the dogs would be faster and more efficient then?
I think the dogs could scout a lot more canola plants because they don't have to pull them up out of the ground to do the detection. So I think for a survey or for a scouting perspective, you know, the dogs can look at a much larger area in the same time that we could pull 100 roots. So for people that want to increase the speed of scouting, or you know, even for counties that are doing scouting for regulatory purposes, these are all places where I think surveillance, monitoring, and scouting the dogs could help speed things up.
They could also pinpoint the areas of the field where you might want to actually dig the plants up and look.
Exactly, and as Bill was saying, you can combine the high tech with the low tech and put the GPS collars on them and just turn them loose in the field and then look to see where they stopped to alert and then go inspect those areas of the field.
Yes. Questioner there, you grab the mic if you would.
Oh. So I understand that this is just proof of concept right now, but I'm curious if you've given any thought to how you might disinfect the dog after it's been digging up clubroot so it doesn't run over your field spreading it.
Yeah, that's a good question. The amount of risk of clubroot moving from field to field is directly dependent on the amount of soil that's moving. And so, you know, in the fields that we had the dogs, they weren't muddy fields, the dogs weren't covered in mud, so it was really just a matter of washing their feet. But in cases, you know, if the fields were muddy and the dogs were covered in mud, they'd have to have a pretty good bath to make sure that all the soil was removed from their feet. I discovered, and I didn't know this, but they already make booties for dogs. You can get them at Cabela's. I guess for hunting dogs to protect their feet, and there's also vests to protect them from getting injured. We also didn't know if running through a canola stubble was going to injure the dog's noses or chests, and turned out to not be the case, but there is personal protective equipment for dogs, and I didn't even know that. I found that out. Sure.
Addressing that question, we in training accelerant detector dogs to go in after a fire to check for arson, there's a lot of burnt material, a lot of carcinogenic materials there. So the dog has to be deconned afterwards as a matter of procedure, even to the point where the dog is trained to put its head down and syringed its nose out so it will sneeze and clear its nose out. So those are all behaviors that can be trained into the dog.
Excellent. Other questions? Well, I would have, before I heard of this project, I would never have thought that dogs could be used for this purpose. Good on you guys for taking it to all the stages and the collaboration that went into this. Let's have a nice round of applause for these gentlemen.